Hi, my name is Michaela Risser. I'm a materials engineer here at Relativity Space, and I handle production testing in the Met Lab. So what we filmed today was a tensile test. We do that for all of our production prints. So we take that tensile coupon, it's a dog bone shape we call it. We pull that on a tensile frame, and after that we get a measure of the stress and strain that it breaks at, that it starts to yield at. Your elastic modulus, that ratio of stress and strain you get for that elastic region, and as well as those final measurements of the elongation, reduction of area. And those points on that graph are pretty standardly what you're looking at when you're trying to figure out the properties of what your material is. The way that these tests kind of inform the rest of the company and the rocket as a whole in the production process really has to do with a quality check as we're going through the print. If for whatever reason we're testing something and we find that its elongation or its ultimate tensile strength or its yield stress are below what we expect it to be, we can flag that as a non-conformance. We can take that to the PBF team, or we do take it to the PBF team and to the M&P team, and we say, hey, we noticed that this material is performing below properties or below what we expect it to. And we can determine with that team then, have a conversation and say, okay, well, is that a risk to the part? Is there a problem with the print? We start doing more testing like metallography, looking at fracture surfaces with microscopes or with our scanning electron microscope, kind of look into what are the reasons it could have failed below what we expect it to, and kind of rule out any problems with material. And if we do find problems with material, we can flag that part, put it at risk, and then make a decision about what to do about it. So the most fun part about doing these tests is definitely that break at the end. Most of your tests are sitting there watching it, watching paint dry, watching metal stretch, you know. But the very end, you're actually breaking metal. And there's not many things in everyday life where you get to do that. It's very specific to engineering, I'd say. It makes a nice loud bang, everyone flinches. You think you get used to it, but you know, weeks, years down the line, you still are flinching at every break because it's still exciting and still cool and fun to watch.